Okay, hi. So here we will talk, in this video we will talk about multi-loop circuit. So that's an example of multi-loop circuit. So we have two batteries, three resistor. So if you look about it, if you look carefully, you will figure out that R1, R2, R3 are clearly not in series and they are not in parallel. Although they look like parallel, but there are batteries between them here, so this resistor, they are not in parallel. So how to solve this kind of problem, meaning how to find I1, I2, and I3, current in each branch or in each resistor. So what we will be doing, so we have three unknown, I1, we don't know I1, I2, I3. Three unknown, we need three equations. So the first equation that we'll use is junction rule, and we choose point, let's say. So we choose any point we want. Okay, so let's choose a point D. So at the point D, how we can write junction rule? We have what current entering the junction, I1 and I3, I1 plus I3, equal the current out from the junction, that's current 2, I2. So that's our first equation. We need two more equations, and the two more equations are loop rule. So we need to take loops. So let me take, for example, we need to take two loops actually to have two equations. So let me take this loop. I start from point A and I come back clockwise. That's my loop 1. So loop 1, how we can write a loop rule. So let's see. We have minus E1 minus R3 I3 and plus R1 I1 equal 0. That's our second equation. We need another loop. Let's take B, point B, and I take this loop. That's my second loop. So loop 2. Right? So let's write our loop rule. E2 plus R2 I2 plus R3 I3 equal 0. We have three equations, three unknown, so solving equations 1, 2, 3 for the unknown I1, I2, I3. Three equations, three unknown. There are methods, mathematical methods to solve this kind of system of equation. So let's see here practical example. So our sample problem here. So in this sample problem, we are given this circuit, and we have the value of E1, E2, and E2. So E1 equal 3 volts, E2 equal 6 volts. We have two resistors. We have 5 resistors and two resistance, R1 equal to 2 ohm and R2 equal to 4 ohm. And the question is, what is the current in the circuit? So the direction of current is already given, but there is no way how to guess what is direction of current. Okay, so we choose the direction that we want. Okay, we choose one junction and we choose what is the current coming in, what is the current coming out, and we solve the problem. If all currents are positive, then that's fine. If one current is negative, it means we take a wrong decision on the direction of that current. But do not worry, things are simple. Let's see how to do that. So we take this point here, point A, to write junction rule, junction rule at point A. The current coming in is I3, and the current coming out, I1 and I2. So that's give me my first equation. We take loop rule. So the loop that I will take is this one. That's my first loop. And by the way, that will be my second loop. So loop 1, let's write a loop rule. We have minus R1 I1 minus E1 minus R1 I1 plus E2 and plus R2 I2 equals 0. That's my second equation. And the other loop, loop 2, let's write a loop rule also. We have R1 I3 minus E2 plus R1 I3 plus E2 and plus R2 I2. So you need to start from the same point and come back to the same point. From one point and come back to the same point. Right, that's my three equations. That's equation 2, that's equation 3. So solving this three equation for 3 unknown. So if you put the numbers, you will obtain this kind of equations, system of these equations. I3 equal I1 plus I2. Second equation, it will give you, after working out, 4I1 minus 4I2 equal 3. And the last equation, it gives you 4I3 plus 4I2 equal 0. Okay, just you plug these numbers in here. So how to solve this kind of system of equation? So we will use a method that you learned in calculus. So let me write the system again. So that's I3. So now it's just mathematics. I3 equal R1 plus R2. 4I1 minus 4I2 equal 3, and 4I3 plus 4I2 equal 0. So from this last equation, actually, what you can guess, what you can see, I3 equal minus I2. Okay, so we take this formula and we put it in the junction rule. What we will get? We will get I1 plus I2 equal I3, which is minus I2. So we can deduce that I1 equal minus 2 I2, right? So we will have a system of two equations now that are 4i1 minus 4i2 equal 3 and i1 plus 2i2 equal 0. This one basically, it's here. And we solve this system of two equations to unknown now. So how you can solve it? So we take this and we plug it here. So you will be deducing that 4i1, which is minus 2i2, minus 4i2 equal 3. In other words, minus 12i2 equal 3, or i2 equal to what? Minus 0.25 ampere. So look here, we have a minus, we have a negative current, but don't panic and don't change this value, keep it minus. So you change the values to positive current just when you finish calculating all the currents. So we will use this negative value and we will calculate I1 and I2. So from here, for example, we get I1 is equal to what? I1 is equal to minus 2I2. So you plug the minus 0.25 here, so you get 0.5 ampere. And the I3 is equal to what? So I3 is equal to minus I2. So it means 0.25 ampere. So we will summarize now. Okay, so we will summarize here what we found. We found that our calculation shows that I1 equal 0.5 ampere, I2 equal minus 0.25 ampere, and I3 equal 0.25 ampere. So this current is calculated correctly, direction is good because we have positive current. This current also I3 is positive, so direction of I3 is this way. We did a mistake here. So actually what we can say here at the end, conclusion, is that the current I2 is actually equal to 0.25 ampere plus 0.25 ampere in direction, in the new direction shown in red, for example, shown in red. I take here red color, and the direction of I2 is not this one, direction of I2 should be this way. That's the true direction for the current I2 in the direction shown. Okay, shown. And that's it. That's the way how we solve this kind of problem. Okay, so there are different ways how to solve this system of three equation, three unknown that you learn it basically in calculus. You can use whatever you want. You can try it in this example, and these are the result, the solution of that, of the system of different equation. So you can try other methods, but the solution it should be the same. All right, thank you for watching. See you in our next video.